everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In last class, we already discussed emitter bias circuit configuration. We also discussed that how emitter bias is used to overcome the limitations of fixed bias circuit. Now in this class, we will study the stability factor or stability of emitter bias, that how it is better than fixed bias. Let us discuss. So this is the circuit of emitter bias. Now we will discuss the stability factor or stability. So we will apply the KVL in the circuit. According to KVL, the VCC is nothing but IBRB plus VBE plus IERE. We are applying KVL in the input loop. So this we are considering. This voltage drop is nothing but VBE and here the voltage drop is IBRB and here the voltage drop is IERE. So if we are considering the input loop, the basic equation we come with VCC equal to IBRB plus VBE plus IERE. Now we will solve this equation to find the stability factor. So again I am writing the equation. VCC is nothing but IBRB plus VBE plus IERE. If I consider IE, then IE is nothing but it is addition of base current of collector current. So we can replace it by IB plus IC. So IBRB plus VBE and we are replacing this IE with IC plus IB. So IC plus IB into RE. Now if you further solve, then the equation will become VCC equal to IBRB plus VBE plus ICRE plus IBRE. So this is the equation we will get. Now we will differentiate this equation with respect to IC. Now we will differentiate this equation with respect to IC and we will make VBE is independent of IC. So VB is constant here. Now d by di of VCC. VCC is also constant. D by di of IBRB plus d by di VBE, VBE is constant, plus d by di ICRE plus d by di of IBRE. Now differentiation of constant is 0, so this term will become 0. Here RB we can take it as constant and DIB upon DIC. Here also VB is constant, so this term will become 0. Now we will consider this term. So RE we can take common and this is DI by DI, DIC by DIC. So it will cancel out. Now here RE we can take here and DIB upon DIC. Now we will write the equation in particular manner. So what is happening here? I will write the equation again. So this will become 0 RB DIB upon DIC plus this is RE, DIC cancel out. So this is only RE plus DIB upon DIC RE. Now we will calculate the value of DIB upon DIC from this equation. So what is happening here? If I take common DIB upon DIC, here I will get RB plus from this we get RE and this is also RE. Okay. Now if I further solve, we will get, if we take this RE this side, so this is nothing but this is plus, so this is minus RE and this is DIB upon DIC RB plus RE. Now if I take the final value of DIB upon DIC, so we will get minus RE upon RB plus RE. So now we will get DIB upon DIC, which is change in base current over change in collector current, and the value is minus RE upon RB plus RE. So we will put this value in the stability formula. Stability formula we already calculated in our earlier classes. So what is stability factor? It is nothing but 1 plus beta upon 1 minus beta DIB over DIC. So if I put the value of DIB over DIC here, what will become? Stability will become like that. So S is nothing but 1 plus beta, 1 this minus, and here also we have minus. We have the value minus RE upon RB plus RE. So this will become positive. Okay, so this will become positive. So beta RE upon RE plus RB. Okay, so this value RE plus RB we will put it here. Now, if we further calculate this equation, what we will get? S is equal to 1 plus beta upon, we will take RE plus RB as numerator. So, this will become, if we take LCM, RE plus RB plus beta RE, and in denominator we will get RE plus RB. If we take this term above, then stability will become 1 plus beta RE plus RB upon RE plus RB plus, this is nothing but beta RB. Okay, beta RE. Now here we can see that from this RE and this RE we can take RE common. So this will become 1 plus beta. Similarly, this is RE plus RB upon RE common 1 plus beta and then plus RB. Okay, so this is the stability. Now here we have to consider few terms here. Like in this equation, the first term is RB is very smaller than RE, or we can say that emitter resistor is very greater than base resistor. So we can neglect this RB. Okay, so we can neglect this RB. And second one is beta is very greater than 1. So we can simply consider beta plus 1 is nothing but beta. Why so? Because adding 1 in beta is the change in adding 1 in beta is not that much, because beta is very greater than 1. So we can simply consider beta plus 1 is equal to beta, and the second term we can neglect the base resistor RB. So what will happen then? This 1 plus beta is nothing but beta, and if we neglect this RB, then only RE will left. And here also this RE, 1 plus beta is simply considered as beta. So this is beta RE. And here RB we can neglect. So the stability beta RE upon beta RE, so these both are cancelled out and the stability factor is 1. So we can see that here the stability is 1. 1 is the maximum stability, or the maximum output, better output of the transistor. So in this derivation, from this derivation, it is proved that the stability of emitter bias is very higher than fixed bias. In last class, we already considered overcome the limitation of fixed bias, and in this we completed the discussion on stability factor of the emitter bias. So we can clearly see that stability of the emitter bias is 1, which is very much high in case of transistor stability. So this is much for today. We will discuss another topic in our next class. Till then, thank you so much.